get into my into YouTube. So for now, just let me get my desktop hooked up. Okay, so what we want to do is we're gonna take the Redux example that they have in Redux repo. I haven't looked at it in a while, but we're gonna try to get this shopping cart example that they have in here and convert it to microstates, yeah?
Sounds pretty cool.
All right, so let's see. So the first question is, how much of this do we need to change? Because I wonder if we can just use what they have now and just modify it, or we need to, or create a new project and just copy and paste stuff. Let's see. Let's see where, first of all, let's just clone this project and Microstates Redux shopping cart. Oh, that's a long name. Oh, and I spelled it wrong. Okay. Redux. Hold that. Okay. So just first of all, let's clone. Let's clone this first. So how did you, how long have you, like, if you've, what's your history with microstates? Like, how did you find out about it?
So basically, I listen to kind of every podcast I can get my hands on. And I heard it on the, I believe it was JS Jabber podcast. And, you know, I've been recently kind of exploring different, I don't know, different solutions around certain things. And I got really fascinated with the idea of state machines and state transitions for UI components. And, you know, the whole immutability set of libraries out there sound really compelling, but have always been, I don't know, maybe a little awkward with how much they change the way you write your JavaScript. Mm-hmm. And then I'm also a really big TypeScript user, as well as on a project that uses Flow. So anything that, you know, gives me some kind of type guarantees is really important. So the moment I heard about it on the podcast, I had to, you know, start diving in a little deeper. So I tried to find some material and look for talks and that kind of thing. So I believe I found a couple talks from both yourself and what's the name of the other guy who goes by Cowboy D everywhere?
Charles,
yes. So I found, I think, a couple of his for maybe an Ember Conf or something like that. Mm-hmm. But as somebody who works in, you know, just a really big project, a really big React Redux project, you know, I can't just like pop it in there. I kind of need a way to kick the tires a little bit. Mm-hmm. And so, you know, so I've been trying to figure out that. And that's when I reached out to you to just say like, hey, there's some example of how you bolt it into Redux when you're already, you know, in the middle of a project, more or less. So I can kind of see how it would work.
Okay, sounds good. It's yeah, it's interesting, especially with Redux. Like, I think there is a lot of it's one of those things where like we see a lot of ways to make it super easy, and that's always our goal. Part of the reason why we spend so much time working on Microstates is because sometimes you need to build a foundation that like something that is encompassing enough to be to lay like enough foundation to be able to build on top of. Oftentimes requires a lot of work to like figure out, you know, because that's the really tricky part, is finding the right foundation. And once you find that, it's actually building on top of that is much you know, it's easier, assuming you got the right foundation. And so we spent a lot of time trying to design that. But then, you know, there's the second part is once you lay the foundation is going in and actually integrating it with all of the existing options to make it easy to use. And so we see a lot of ways that we could be like super easy with using with Redux, but at the same time, I don't it's like we're limited by the time that we have, and we don't use Redux that often, so it's a little bit like it's definitely not. I mean, we made Microstates in big part to kind of avoid Redux, but but at the same time, a lot of people use it, and so we want it to be easy for people. So we have some ideas on how to make it super easy, but I think for now we'll just kind of see how they work side by side, and then we can talk about how they work together.
Yeah, awesome. I think everyone has a different Redux stack too, so that doesn't make it any easier for you guys. Everyone has a flavor of how they kind of do Redux.
Yeah, and I think I actually I'm really excited about what's happening with hooks, and I think it changes the conversation about Redux quite a lot, because a lot of the functionality that you have in Redux, or a lot of the value that people like reducers, you could just use with use reducer hook. And so it diminishes a little bit of the value that Redux has, aside from the ecosystem that it has as well. Like that, there's a lot of stuff there, but a lot of those ideas are also making it into React itself. So it's not. So I think the target is always shifting, for what kind of integration you need. So let's see what we have here. All right, so adding to cart and then using checkout. Okay, all right. Please add something to the cart. Okay, so it diminishes the inventory and then checkout. Okay, so let's see. The question is, where do we start modifying this? And what is the so this part? Okay, so let's see what the entry point here is in the app. The rendering products container and cart container. So it's these two things, cart container and nav state to props. Okay, and products container. Okay. So all right. Let's see. Product item. Okay, so product item gets title, price, quantity button. So it's one of these, and then you click on cart. Okay, so that seems pretty straightforward. One of the things that's a little bit different, one of the things that's a little bit tricky about thinking about like how to convert these things to microstates is that, as you were saying, that it's different. Some tools, when you start to use something different, requires a different ways of thinking about, especially when we're working with immutability. So Redux works in the same paradigm, but the shift when thinking with microstates is that you start thinking about the shape of your data and building up the shape of your data, and then reflecting that shape, or reflecting that state in components. So it's similar in a sense that you have this kind of a separate entity that has all of your data and your state, but it's different in that the actual you program the shape. Like when you're building a microstate, you're programming the shape, and then you're binding that shape to the component tree. Versus,
would you kind of say that it's sort of like a data modeling first approach?
Yes, definitely.
Gotcha.
Yeah. So that's what I'm thinking, and so part of the challenge there is that there's certain parts are easier to do, and then it gets even easier with some additional tooling, which we're still in the process of building. But I think we can build quite a lot with what we have right now. So okay, so let's see. So one of the one of the nice things about microstates is you can go look at the data type. You can see the shape of the store. With Redux, you have to try to kind of figure it out from the reducers, which can be tricky. Like looking at these things, it's hard to see the shape.
Yeah, whenever you see list in the Redux store, it's just an empty list to start. You never get the shape of the object that goes inside.
Yeah. So you kind of have to figure it out from how it gets mapped into components. So let's see. Product container. So product container is got a product list component, product container. So there's a mapping, some actions, get visible products, state products, products. Yeah, so that's the products. So let's see. I wonder if it would be easier. There's not a lot of CSS here, so I was kind of hoping we'd be able to reuse some of that, but there's none of that here, so it seems pretty simple. Let me see if I can figure out what the actual shape is here, and then kind of go from there.
Would we be able to take the running app and if you have the dev tools installed at all, maybe just pop into the store and kind of pull out the snapshot? And one of the things I do a lot as a TypeScript user is pull out the runtime data and dump it into like JSON to TS, which just sort of says like, okay, here's an object with a shape. Can you kind of determine types for me? So I don't know. This is maybe a similar idea to do that.
How would you do that? What do you describe?
So do we have the Redux Dev Tools available in your console view?
I have React, but I think not Redux.
Probably not Redux.
I can restore it.
So we could always just put a handle to the store on the window object, so it's global, and then we could just grab it that way.
I can install Redux Dev Tools. Let's just give me a second.
Whichever is easiest.
Yeah. Redux Dev Tools. Okay. Okay. Yeah, so we have Redux Dev Tools now. Redux.
So if nothing else, we might not have to do any like copy and pasting, but we could kind of side by side and look at, at runtime what the like inventory probably has all the products in there, and so when products move to the shopping cart, it's the same data structure.
So here's I think I can see it here from the received products. I'm not sure where received products, maybe it's an AJAX request. Oh yeah, API products JSON. Yeah, okay, so it's coming from, there's a kind of a mock API here. So
okay, well then that's kind of most of our data shape anyways, I imagine.
Yeah, so let's see, we've got received products, okay. So this is what the actual, this is what the data looks like. So we've got a cart with added ID, quantity by ID, and the products by ID.
Visible IDs, okay.
Visible IDs.
So it looks like a product has an ID, a title, price, and then inventory or quantity is the same idea.
ID. Yeah, and so this is pre-populated.
Yeah, that's that mock store, I think.
Yeah. So what do you think if we just started from scratch and just build it from scratch, as opposed to trying to modify this, just use it as a reference? Because I think we can use all the same components and just kind of build it up, as opposed to trying to
yeah, that works for me.
Rebuild this or modify this. Let's see if we can. So Microstates cart. Okay, so let's just do create. Yeah. There's a normalized data store thing in here, and I'm thinking, well, type situation of this whole product by ID business, and I'm like, I really wish we had that. We have an experiment that's pretty far along that would be like a, a normalized data store data type, a microstate type. So just like so you can wrap some different data types over or different types over, wrap them in a normalized type, and it gives you like a fully set up normalized data store. So
That's pretty cool.
like, yeah, like I want to use that, but it's not fully ready. So I'm just like, but let's see, yarn add microstates. Yarn add microstates react.
So I guess you could say that my hope here is that like there's a lot of things I do actually like about Redux, but one of the things I'm hoping that Microstates, so I know a little bit about some of its, sort of its guarantees, which is what gets me interested in the first place, like the idea of lazy computation for doing state transitions, the idea of immutability, and then the idea of kind of like the persistent data structures so that when you make an immutable change, like only the pieces that need to change. You don't have to, sometimes I think that when we write immutable JavaScript, we end up, I don't know, copying a ton of data rather than just what we need. So besides all that, I'm really hoping that like the act of writing reducers kind of vanishes, or at least gets way easier. So that's what would get me really excited, I guess. Remove a lot of boilerplate.
Yeah, I mean, so you could. The tricky part is that. So what I'm hearing is that like you would like to kind of primarily use microstates inside of Redux, as opposed to instead of Redux.
I'm open to any way, like whatever Microstates does best. There is the concern that like if I have my current production app, that I might have to find a way to integrate them together. But I guess you could say right here and right now, I'm kind of curious about like Microstates at its best, like where it shines the most. So if that's like as a replacement for Redux, then that's totally fine to look at, right? Because if that's how it can reduce the most amount of boilerplate for me, then that would be, that's what I'd be interested in, I guess.
Yeah, I think part of the, so we can do, we'll do microstates instead of Redux for now, but I think I do have, like, we actually have some experimentations of what microstates inside of Redux would look like. It's just, we don't, let me see if it's, yeah, Microstates Redux. So the idea here is that you would essentially, you can put a microstate into as one of the parts of your Redux store, and then you get from your store you get state, and then instead of getting explicit actions and writing the reducers, you just get your operations that you can invoke. Your actions are part of your state, and so you can just invoke them right off the state, and you don't need to be like explicitly doing anything with the reducers. But this is not like this is I think an experiment that Charles wrote, but I think it's not fully aligned with the current version of Microstate. So I think it's like work in progress that can shape up. I think part of it is that we don't have a lot of motivation to write this because we don't use Redux that often, like I said. So if there's someone who wants to make this happen, like we can actually, like we'd be happy to support them in actually making this happen. But for now, I think we'll just focus with microstates without Redux, and then just kind of see what that looks like.
Yeah, that sounds great.
So okay. All right, so I'm going to start this project here side by side so we can see what it looks like. Yeah, start. Okay, so I think what we'll do is we'll start with So let's just first of all start with the products by ID. So these are by ID.
Yeah, so they're keyed with their ID, but they should be the product data structure itself.
Yeah, I'm thinking because I think what we could do is because by ID stuff we could derive this off of the unnormalized. I think that would be probably the easiest way to go for now. But I'm also thinking whether we actually need to. Okay, we're going to copy the product into the card, so it's going to be referencing it by ID. Okay, let's just do that. So we'll have references. We'll use references. It's let's just do that. So we'll have a products is going to be there's going to have an array of products, and then we're going to reference the products by ID. So we're going to key off. We'll create this ourselves essentially. So and then we'll start off by let's just try rendering this list first, list of products. So we'll start with just the initial data that we have here in the API. Products JSON shop. Okay, so we'll just take this for now, and we'll create a. So let's just create. Let's start this project.
Not going to try and listen on the same port, is it?
I think it's gonna ask me to run it on a different port. Yeah, there we go. Let's add another port. Yeah. Okay. Okay, cool. All right, so let's remove all this. Okay, let's import use type from Microstates, React. Okay, so now what we're going to do here is let's just use which version of it's the latest version of React, so I think we should be fine. I'm just going to use function here. Okay, use type. Okay. All right, now let's create a microstate here. Let shop equals use type shop, which we don't have yet, and then we're going to have our initial value here. Let's take our initial value. These are going to be let products, either products. All right, so let's create our shop. Class shop. Products is going to be an array of product. Class product. Okay, and then so then we'll do. So it has ID, which is a number.
So just a quick question on this, because I've kind of gone through the sort of the tutorial stuff on the repo, so I know what you're doing, but but I'm just, I guess, for other listeners as well, like if they're not using some of the newer Babel types of things to transform class properties, these could be also assigned in a constructor, right?
Yeah,
so, I mean, that's kind of what this all desugars out to anyways, right?
Yeah, constructor like that.
And then you just say this.id equals number, the number constructor kind of thing.
And then it'll be like this dot, like that.
Okay, yeah, just kind of for like clarification, because when I tried to spin it up and just, you know, like vanilla Node, if you will, I was like, oh, right, I can't do that.
Yeah, it's that's one thing about Node, and I'm actually dealing with that right now. Another project is trying to get a set up another project in Node right now. But yeah, it's Node doesn't support this yet, but I think it just recently moved over. I think Fields recently moved over to stage 2, so I think there's hope that it's going to be moving in the right direction. That we're going to see it in the future. So keeping fingers crossed. But it's just not, but in a lot of tools are starting to use this. Like a lot of libraries that are dealing with data structures are starting to use this way of defining types. Like I don't know if you have any interest in other frameworks, but in Ember they have this tracked properties proposal which has something similar. So it's a popular way of it's a nice way of describing data.
Kind of like a runtime reflection that you can do with like this sort of almost like a descriptor object.
Mm-hmm. What gets a little more complicated is like how do you use this with TypeScript, and that's something that I've been trying to deal with for the last little while, but that's kind of like queued up for me to work on essentially. So all right, so now let's just let's just get this rendering so we can see we can see this list on the screen, and then we can go from there. So what do we have here? This is going to be just the products, and then the title, and then price and inventory. Okay, so all right, so it's going to be H3 products, and then so now what we're going to do is, so this object, actually before we do this, we could probably just console log this object, log shop.
If I remember right, you just kind of get microstate of shop.
Yeah, it should be a store wrapped object. So it should be a microstate that is wrapped in the store that we can interact with, a microstate store as opposed to a Redux store. Let's see what we have in here. Reference, yeah. Here we go. We got our. So we can do. Let's see if this object here, store global reference temp products. They should have, and this has a whole bunch of transitions that we can invoke on it. I want to see length here. They should have m.products.length. Wait, okay, perfect. Zoom this up in a little bit. Okay. All right, so now let's get this list rendering. So we're going to use the map for microstates because
because the product is not a true array, it's a wrapped array.
Exactly. It's an iterable. So you have to. So there's kind of different ways we could do this. We could spread it. Yeah, we could just spread and then map over the array, or just use the microstates map and then pass it shop.products. And then we'll just map this, and then it's going to be if li, and then we'll do here is product, and let's give it a key, product.id.state, and then this is going to be what do we have here? It's think title and then price. So let's just do product.title.state, and then product.price state, and then at and then product.title.price times inventory.state.
Just doing that so that you don't have the weird JSX wrapping with spaces.
Yeah, just make it a little bit easier here. Let's see if this is actually working. Format. Oh, what is it not happy about? Oh, it's a return. There we go. right, so let's see. So we have here title, price, inventory, state, product, product ID, state, title, state, price. Oh, this is not right. Price. Okay. All right, so we got a list of items displaying. Okay, so now, so then the next step. So let's see what are the things that we have here. Shopping cart here. So add to cart, and then we got cart. Please add some products to the cart, and then when you add a product, it shows a thing. So let's do the cart next, and then we will figure out how to wire them together. So the cart has the list of each of the products, and then it has calculation of the total. So let's just do that next.
So were we going to do that where the cart was just the reference to the product?
We can do that. That would be, so we could, yeah, so what we could do is we could make a cart a reference, then compute inventory.
Because what you end up with is we have our products and they have a defined inventory. So you don't really want to change the product for what's in your cart. You just want to, I guess, you know, maybe this is non-microstate thinking, but just tag which ID product you have in your cart and how many you have. That would be kind of like the most normalized thing, I suppose.
Yeah, that would likely be the easiest thing to do at the moment as well. Thinking, so let's make a let's create a normalized version of the products so that we can then retrieve them by ID. So it'll be easier for us to look it up down the road when we actually start to do that. So I think we could just do here, just create a getter. So it'll be products by ID, turn this dot. So what we'll do is we can reduce the, so let's reduce the products. So reduce this dot products, and then it's going to be a function. That's going to be the reducer function, and then we're going to have the initial, which is going to be an object. So then return, we're going to get each product here. Oh no, sorry, this is going to be accumulator product. And then, so let's just do spread accumulator, and then product.id, and then the actual product.
So curious on this one, when you have your array helpers, and you mentioned that microstates, well, at least certain, you know, like array microstates are iterable. Because what I'm imagining is that when we do this reduce and we get a products by ID object where, you know, we have our product IDs as the keys and the product as the values, that whole object itself is probably a microstate. Versus if I just do like a for of loop through the products and I put that in an object, then I would be returning a plain object, right? Or would like the internals of microstates know to wrap that up in another microstate?
In this case, so sorry. So you mean the question is if you were to just do this, like this dot products, right here?
Well, not exactly. If I was to do like a traditional way to create this sort of accumulated object by saying like, you know, let products by ID equals empty object.
Like that, and then just do like for
for let product of products, or you know, the base dot products, I guess, because you said they were iterable. So
yeah,
you know, the theory this
that would work. Yeah.
And then I would assume I'd just be, you know, products by ID at product.id.state, right? I still have to pluck it, like, plus the state out of it, I guess.
Products by ID, yeah. It needs to do products by ID, product.id.state.
Okay.
And then equals
Product.state, I guess.
Yeah.
Or just product?
Just product, yeah. Because I mean, you'll still be able to. The nice thing about keeping it as product is that all of the transitions on this object is still going to be functional. So you'll be able to invoke like the result of this. So if you just do like return product products by ID, the result of this, the objects that and the result of this are going to be microstates that you can invoke transitions on. But the actual object itself is going to be a simple object. It's just going to be a POJO.
Right. So that's kind of getting at the ultimate part of my question, which is doing it this way right here at the top of products by ID returns a plain object of microstates. Does the reduce helper return a microstate that is the whole, you know, thing as well?
It won't be a microstate, but it would be a query. So query, we don't have queries documented in microstates well, but because they are composable operations that follow similar rules to microstates. So they're lazy. So like this operation would be computed when it's actually invoked. So we can see what let's see what this actually the result of this is.
Sure. Let me let my dog out one quick second. Sorry.
Yeah.
All right.
Products by ID object. So these are so this is essentially, I mean, it's equivalent. These are, for all intents and purposes, these are basically equivalent. So it's not. It's just functional way of writing this as opposed to the like imperative way of writing it.
Yeah, that's just really helpful for me to kind of see like how many things are sort of library specific versus like just JavaScript, I guess.
Yeah, there is, and actually I think reduce is not even, let me just take a look at the, this is a pretty new part of, a lot of the stuff around these queries, oops, what's going on here? They came from the work, performance work that we've been doing. So some of the stuff is kind of new. We'll just see what microstates and query stuff is actually, we want to pull it out into a separate library. We'll still likely have, like, it will still be the same exports, it's just different library. Let me just take a look at how this query reduce, generator. So that is reduce iterator, call a function on each, return the result. Yeah, so the result is whatever the actual result is. So there's nothing special about it. And then all that it's doing is it's just it has a way of working with iterables that is like it just knows how to work with iterables. Because alternatively, what we could do here is like this way, or just doing return spread operator this products dot reduce. This would also work.
Right.
The one difference is I think.
Well, technically, when you do that spread, you kind of call like array.from, and what you're not doing is not doing like a mapping function. So you end up doing an extra iteration, which is a small cost in this case, but potentially important.
Agreed. Okay. So I'll just stick with this for now. So let's see what we got here. So I think this should be, let's see what we have, the reference here, product by ID in each of the references. And so now if we were to, let's see what happens if we just do, I want to grab this object, temp1 dot products by ID, and then do 1, and then inventory dot increment. Let's see what happens. Inventory. Okay, hold on. I didn't see what the. Yeah. So it's this first one. Or let's see which object are we. ID 1. I don't know what. Oh yeah, iPad 4. Okay. So ID 1 incremented. Oops. Hit temp. Grab the go into it. This is going to be products by ID 1. So ID 1. So that's going to be iPad 4, and then inventory, and then increment, and then it gets updated up here. So that's what. Okay, so that's part of the reason why. This is the reason why we want to keep the. Use the actual microstate as opposed to state, so we'll still have it like functional, like working microstates.
Yeah. So what seems pretty cool to me right away is that we just pulled state out here and, you know, in big air quotes, mutated it, not literally, but it's somehow integrated into the React component well enough that it also called set states to force a re-render.
Exactly. Yeah. So that's what. And so
magic.
Yeah, and it's it's definitely for the amount of work that you need to do, it definitely seems like magic. But
Oh yeah. So use type is basically a hook.
It is a hook. Yeah. So it's a hook that internally just let's see if I can actually. Oh yeah, I can actually see it in here. Yeah, so internally, it references, it just uses useState, and then just sets up the microstate store, and on the callback calls setState from that useState operation.
Yeah. Okay. Really cool.
So now we've got our. Okay, so now we can do. So now we have an easy way of referencing this product by ID. So now we can build a shopping cart, and so our shopping cart is going to be it's going to be a list of products with their inventory, and then we're going to do a summary, which is going to show us the total in the cart. So let's do first of all, let's make an array of IDs, which is going to be. So what do we want? Do we want? I guess we probably want it to be a little bit more than an array of IDs. We want it to be
right.
We want it to be an object that has keys, that has
the ID for the product and the quantity that you're having in your cart.
Right. We want the quantity. Okay. So let's see if we can express that here. So cart is going to be a.
So this is kind of interesting because in a way we have kind of like a different kind of product view, if you will, where it's just we kind of pull out the title and price in a way. So I know inheritance and functional are kind of at odds because functional prefers composition, but because these are just simple state primitives that we're using, OOP for in air quotes. Could you take like class base product and it has an ID and an inventory, and then class product extends that and then adds title and price, and then you can make your cart an array of base product? Or is that not encouraged? Are there some gotchas there?
You can do that. We've been going back and forth quite a lot on whether or not, like, how deeply we should support inheritance, because one of the things that we're starting to lean pretty heavily towards is that we probably want to use like higher order types for doing inheritance as opposed to doing like class-based inheritance. So you would do is like when you want to have something extend something, what you would do is you would have like a type, you'd have like a function that creates your like specialized kind of product. So it'd be like let's say like what would be an example? Well, what was the example you used?
Yeah, so basically I'm looking at our class product right now and thinking about the kind of product that we're going to want in our shopping cart. And essentially they share two properties, right? They need to share the ID, and they could share inventory unless you wanted to change that to quantity, but basically they represent the same thing, how many of this product. So, you know, in the sense of normalization, you kind of say, oh, well, like the product that we keep in the products array is just a more expanded version. So I could do some kind of inheritance there since we're using classes. But again, you know, like mixing functional and OOP paradigms seems a little bit like oil and vinegar. So it's kind of, you know, am I getting ahead of myself, or is that fine because they're just primitives that we use as descriptors?
So it will work. So the thing is, like, so this will actually work. So if we do, like, so let's say we have product and we want to have, like, we want to say inventory product, extends product, and then this just has this. We can use this here instead of this, and this will essentially work exactly the same way. This is working now. So this works now. What we're thinking about is that we're starting to think more of like inventory product as being a higher order function. And so I think this is, so I mean, you're right in the sense that traditionally object-oriented programming and functional programming are kind of at odds with each other. But Microstates in many ways is like, well, what if it wasn't at odds? What if they could actually work together? What would that actually look like? What if you got the benefits of being able to understand data and express it as classes, but really, so you get the benefits of the clarity that object-oriented programming provides, but you get the benefits of the clarity of like data in movement, data in change that you get with functional programming. You'll get, what if you could get both benefits? But then the question is like, how does that actually work? And I think one of the things we're kind of starting to lean towards is that, for example, you could have something like this where you have a inventory products function that takes a product, takes a type here, and then what it would do is return class extends type and adds inventory number. This is the pattern that we are kind of starting to move towards.
Yeah, this looks like the multiple inheritance trick for JavaScript.
So we're starting to move towards this as an approach.
Now this, since I'm referencing something that, you know, just out of the blue here, what we're kind of getting at, right, is this idea that in JavaScript classes, well, first of all, classes are kind of just sugar on top of function prototypes, but just considering classes as a new primitive, they can only extend one other class, right? So if we want to have like a base type that's like with ID, right, where all it is ID is number, and then another base type with inventory or something like that, where it just has inventory, which is a number. And then we want to make a product which has a title, a price, and it also extends with ID and with inventory. We can't do that unless we create this like multiple, you know, subclasses. And so by doing the function thing, we actually do the exact same thing. We just are able to compose them all at once so that we can't touch each layer of the subclasses. Is that exactly accurate?
Yeah.
Cool.
Yeah.
Okay.
And so this technique is actually, so if we look at what is it? Where is it? Let's see. If we look at Microstates Union, so Microstates Union is we've known for a long time that there's a correlation between, where is it? Let's see, Microstates. There's a correlation between between types and state machines. We've kind of observed this for a while now in designing microstates, but it wasn't really clear exactly how that works in practice. Like we have like the traffic light state machine, which was kind of one of the experiments in this direction, but this is now starting to formalize the ideas around the state machines and how you can express state machines in microstates. So this Microstates Union will make it into the main repo. And so what this does is you give it, you have a function that takes an object of types, and then and so these are essentially all the different states that the type. So it's essentially like a union represents a place in a tree of microstates, and that place can be of different types. And so, like, what are the kind of ergonomics that you need to be able to transition from type to type, to be able to detect which state you're in. So this union type is going to be kind of providing that functionality, and that's using the same pattern.
So like that example that I see there with the task, does this get at the idea that we could have this sort of state machine that says, like, for example, we have our store with products, but when we load up a web page, we tend to have an empty array of products, and we have to make a data fetch. Mm-hmm. So in other words, we start with an idle state, which kicks off a fetch, which turns into a pending state, which eventually resolves with products or rejects with some kind of a failure. So so I'm trying to map that idea onto what I'm seeing here. Is that correct? Is that like what this could handle for us?
Yeah. So this is the direction that we're kind of moving towards, is being able to express. So you then say you can then say, like, a union. You can have like an async type, a function that will take a type, and that type is going to be the actual value, but it will transition through different states, and then ultimately it might end up with the type that you want. But it's going to, but that location, the microstate, is going to be represented by different types as it goes through the different stages of the life cycle of that place in the microstate, in the actual tree.
So, like typically handling, like, oh, let's show spinner while loading, let's show error when error, otherwise let's show products if they resolve.
Exactly. So the idea here is you should be able to, you have a type, and then if the nature of your type changes, all you need to do is you change you kind of wrap the original type in the new behavior, and then now the rest of the application should be able to behave, like, interact with that type similarly, but then it might have additional features now, like, tracking a state of asynchrony, for example, in that location in the microstate.
So it kind of looks like when you unionize or just union these various states that can be transitioned from one to another, you get these little helper values, like computed values out of the box. Like, you take the name of the state pending, and then you get the let me peek into the state is pending, like, answer that question for me. And then you get transitions to pending, right? Like that kind of stuff is just part of the library. Is that right?
Yeah. That's what the union does. And so you can express, like, you'll have for each of the states, each of the possible states, you declare what can happen, and so you will get, so these get auto generated for you, gotcha, according to the other members of the union.
That's pretty cool. Awesome.
So this is pretty close to I think it's just a matter of moving it over into the Microstates organization. This is like pretty close to being ready, and they're just writing up documentation on how to use it.
Gotcha.
So I want to show you this because it's the same pattern. And the one difference here is that we're actually constructing, like, as you were saying, like, we're constructing all of these.
Yeah.
We're constructing them for each of the members of the union. Okay, so let's see. Let's go back to our example here. So I think this should still be working now. I think we've made some changes, but it should still be working. Yeah. Okay. So, all right. So let's see. I'm going to close this. Close this stuff. Okay. All right. So the next part is what we need to do is we need to have this essentially an object that tracks the which of the I think that should work. I'm just worried about the types, but I think it should work. I'm worried about the types of the keys here because these are numbers, and the keys and objects are strings. I think it should just work, but we will see. So I think what we can do here is we can say that a card is an object of number, and so that's going to be the ID of the ID or the index on this object is going to be the ID, and the number is going to be the inventory count. And so
that's an interesting trick. Yeah.
We can try this and kind of see where this takes us.
Do you guys support map as a type for Microstate?
Map, we don't have map right now, but I think it would be pretty, like, it's just a matter of adding it. You know, it's there's no reason why we wouldn't be able to support
Yeah,
it.
I always feel like map is semi at odds with this idea of immutability because, you know, kind of the idea is that map is efficient at creating and deleting keys or you know, entries, if you will. But at the same time, it leaves you the flexibility of putting any type as a key. So kind of, you know, and this, like you were just mentioning, we'll make this keyed by the product ID, but the key is actually a number and it's going to end up being cast to a string because that's how JavaScript objects work. So just brought it up there.
Yeah, there's there's a lot of things to kind of figure out because there are some other things that are funky when you start thinking about them. Like one of the concepts, it's another thing that is like in the pipeline. But this idea, because right now, create takes two arguments, type and value, but then we have another potential argument, which could be references, which essentially would be things that you can pass into a microstate that are not value. They're not serializable, but you still need them. So it's a kind of like so there's a lot of concepts that as you start to, like, as we build out more complex use cases with microstates, we start to discover like what are the different things that we kind of need, and right. And that's what so far, I mean, that's what happens kind of a lot these days. Like, you know, it's not always crystal clear exactly how it works, and but then once we kind of figure it out, it settles and and becomes hopefully like common knowledge for everyone.
Yeah, like an easy pattern to follow or something like that.
Exactly. Yeah. So let's see. Okay, so now we've got the card. Okay, so now what we got to do here. So let's list our actual card. So what we got here. H4 products. And then cart. Okay, so then actually let's do, before we do that, because we need to actually add things to the cart first. So let's add, we need a way to add things. So let's just add a button here that is going to add something to the cart. So let's do button, add to cart. So we'll add a method, we'll add an operation to that. Okay, so now we need an actual transition. So because we're going to be performing operations in multiple things at the same time, we'll use we'll just create a transition here. So add to cart, and then this can take turn. This is going to take a product. Okay, so then.
So this, if I remember right, this is kind of a reducer in a way, like mapping my Redux spraying. What you're doing with this method is basically going to be what we would do in a reducer.
Yes, exactly. And
Cool.
actually, in very early versions of microstates, the first argument was state, but then
Okay.
we realized that state was actually this. The current context is state, so there's no
Right.
need for us to be passing a third argument. And then it made funky, like it made thinking about types funky, so we removed that, and actually end up being kind of really straightforward. So
Gotcha.
so what we want to do then is so the question here is there's a little bit of a lot of logic that we need to do because we need to see if the item has been added to the cart before. If not, then add it.
Right. Add it if it's not there, increment it if it's there, but also
Exactly.
decrement the product count in the product, sorry, the inventory count in the product array.
Exactly. Yeah. So let's do. So let's just do. We don't have. I'm curious if we have on an object, if there is a microstates. Microstates. Just see what we have. How we do for time? I've got about 20 more minutes. Okay, let's see. No, what I want to look at is the object type. Object. All the things that we can do. Filter, put, assign. Okay. All right. So we don't have. What I was wanting to see is if we have something like has, where we can check but no, we can just do.
Yeah,
okay.
yeah, because you kind of want like a get or put in a way.
Yeah, is that cart product.id.
I'll be right back. Let me get my dogs.
Okay. Then return. Product. It's interesting. There's actually trying to think. There's a little bit of it's one of those interesting situations where product. Oh, actually, maybe the way to do this would be to make this a little bit simpler. Just pass the product by ID here. So on click. So it's going to be shop.add-to-cart product.id.state. I'll just grab the ID here. And then so what we'll do here is instead of this is going to be ID, we'll just grab the actual ID here. So what we'll do here is if we have the ID, then what we'll do is we'll this dot so it'd be this dot cart ID dot and then the next part we'll need to do here.
Inventory increment.
It would be so what we're going to do is we're going to increment this. This is going to return a new microstate for us at the root, and then
right, because it's just ID to inventory count or quantity, I should say. I got it.
Yeah, and then so we increment that value, and then what we're going to do is we're going to do products by ID, and then we give it the ID. Oh no, that's not going to work. the tricky part here is because oh no, this is what will work. Sorry. Okay.
Right.
Products by ID, yeah. And then return here is going to be inventory.
Is there a decrement option or is it increment? Okay, cool. Are you able to do increment and then pass in -1? Is it like a delta type of thing? Oh yeah,
you could do that.
Gotcha.
All right, so okay, if it has current, if it doesn't have current, then this dot cart put ID 0 and then products by ID.
I guess you want to put it at 1, don't you? Because you add it, so you want to add it with a quantity of 1.
Oh yeah, thank you. Inventory by ID, inventory decrement. So what we can do here is we can actually.
Sorry. Isn't there actually one case that we this is making me think of that we haven't handled, which is that if inventory products by ID, if that product has a 0 count of inventory, we should not allow this, because I think right now we can go into the negatives.
Yeah, you're right. I think those are the kind of things that we can probably be easy to flush out with tests, which we can add. And I agree. I mean, I agree. This is the case where we probably want to start off with checking that is working. So let's see if this works first, and then we can add that.
Yeah.
So what I'll do here is I'm gonna break this up into let cart equal let cart if current. I'll just break it up into 2 steps here. I'll do cart equals. Should we just do this here?
Yeah, I was gonna also comment that I noticed that when you retrieved current, you didn't use current to do the increment. Is that because the way microstates work, it kind of needs to keep this path intact?
Say it again.
So
you mean this? You mean this here? No, we can use this. You're right. We can use this here. Yeah.
Okay. Current. I wasn't sure if that was like a gotcha that you have to.
No, I was just
going from the root level down.
No, it was just an oversight here. So that should work. There we go, like that. And then so that puts it into the cart, and then we return cart. I know we just do this part, so we don't have to repeat ourselves here.
Yeah, that's nice and easy to follow.
Okay, so let's see what happens here. So we take the product ID and put it to the cart. Okay, so let's see if this works. Okay, that part worked. I don't know what happened with the actual. Okay, let's see what happens with our actual microstate. So let's see. I'm going to console log it again. Console log shop.
Does our initial object need to have a cart, or? Oh no, it looks like it initializes it for us.
Yeah, and it creates the reference and creates state. It has a value, and then it has this reference ID, inventory state 1. Okay, there we go. That worked.
Cool.
Okay, so now what we can do is so let's handle the other case where it if the inventory is empty. Well, actually, I mean, there's 2 ways you could handle this. I mean, we can handle it at the data type level, which is great, and the other way we could handle it is at the view layer. So let's add it at a data type layer, but really, if you don't have, what we'll do is, if the product has no inventory, we'll just disable the add button, but we'll have both of those. So we'll just do the data layer part first, and then once we have that, we'll change it so that it will disable the product, disable the button when there's no products to add to the inventory. So let's just do the first part first. So essentially what we want to do here is if the inventory is 0, we can't add the product, right? So let's see. So if current cart, so what we want to do is we want to say so this dot products by ID, and then we're going to grab the ID. So, and then we're going to take the inventory and then give it state. So if inventory state more than 0.
I think it's complaining about parentheses versus brackets on the products by ID.
Or is it? Oh, you're right. No, you're right. Well, this is actually, I mean, it didn't complain, but you're right. Thank you for.
Oh, I thought I saw squiggly, but it went away.
So if state is more than 0, then we can do this stuff. Otherwise, we're going to say return this. Do nothing.
Oh, so is that kind of a rule in any of your methods which act as reducers to always return something? Like you can't not return, right?
Yeah, you can return nothing. You can return POJOs, and then Microstates will convert those POJOs into Microstates, but you have to return something. Otherwise,
Gotcha.
it's going to treat it as a value. Like undefined is going to be a value.
Gotcha.
Okay, now let's see. So now basically what that means is that once we get to 0, yeah, I can't do anymore.
Cool.
And so if you notice here, this is, I think, one of the things that we kind of work hard for and it's paying off now, is that there are no transitions happening. There's no actual, like, it's de-opting for you automatically. There's no re-rendering happening.
Because that would be the console log in our render method, right?
Yeah, that would mean that it's re-rendered again, which it's not doing right now.
Excellent.
So now, okay, so now we can actually, so let's do, so the nice thing about having this type already separated, what we can do here is we'll just do has items, I mean, is available, let's say is available, and then return this dot state is more than 0. So, and then we'll do here is button is disabled when...
That right there is actually a really cool piece of functionality to be able to take like this base idea around. So basically we wrap number, right? Like you guys talk about how, hey, numbers, what defines a number is that we can basically increment or decrement it and like do math on it. But what's fun about wrapping number in this notion of being inventory is that we can add operations, like we can tell if it's available or not. And now we can mix that into anything that has inventory. So that's pretty cool.
Yeah, that's definitely a feature that I really like. What it does is it gives you a way to add context to the actual number itself, and in ways that are specific to your particular application. And so in this case, we have this inventory product. So now this product is now getting ability to inventory and also is getting ability to check if the actual product is available. And so,
yeah, cool.
So then disabled, so we can do here is product dot is available. So if we'll do just like not available, then it's going to be disabled. So let's see if this works. Press the button and then it becomes disabled, and then you can't click it anymore. Okay. All right, so now let's do the actual cart part, which is going to be, all right, so.
Yeah, so this kind of just ends up being like a object.entries sort of thing where we do lookups for the products by ID.
Exactly.
Would you use like another one of those helpers? Like you have a reduce helper, a map helper. Do you have like an entries helper?
We don't have entries helper, I don't think, but I wonder if we can use map. We should be able to use map to, well, actually, no, I think map. I think map will work. I think what we could do here is we could use map to, and entries may be something we should add. Well, let me just see. We have.
Yeah, just looking for like an analog to the typical symbol iterator type of APIs. You know, I'd kind of assume there'd be like an entries, a keys, and a values, apart from, you know, things like these more array specific methods like map, filter, and reduce.
Yeah, I mean, one of the things we talked about quite a bit before is that we want we actually want to have the same APIs for working with objects and arrays. It's really helpful to be able to map an object. The one thing is a little bit, so in this case, it's a little bit different because usually a map operation maps to the same shape of data. But in our case, we're actually mapping, oh, actually, no, sorry. Map is a functor, so it's supposed to map to the same data structure. So so a map of an object would map to an object. But in our case, we don't want that because we want to, we actually need to call entries. So we'll get an array so we can then go over entries because we need an array as opposed to an object. So
right, but that doesn't really, I mean, I guess, so I don't feel like it actually violates that idea that like, you know, it should have the same type going in because like in a way you're, you know, when you do an array map, right, you're not mapping the array so much as you're mapping an item in the array. And then when you, so I guess the item in an object is kind of abstract, right? Because like you still need to be able to map the key. I don't know. I guess I follow you, but it's kind of like not apples to apples maybe.
Yeah, I mean, it depends how strictly you're going to conform to the functor rule, which is what map is from, right? And if you're going to go strict, then it would be that the data structure needs to be the same. And I think that's what probably be long-term is probably a good idea simply because if you don't maintain the data structure, then it's just going to be kind of confusing. You know, but so I think to your point, like I think it actually makes it makes sense for us to have entries on the object so we can then get the entries. But let's see if we can do this without, let's see what we can do with what we have right now. So let me just console log. Okay, I'm just gonna take a look at this. So we added a bunch of things to cart. So I'm gonna take the last reference, temp1.cart. So cart is a microstate. It's a microstate. So what will happen if we okay, so what we can do here is we can do object.keys on this. Let's see. Okay, so that gives us keys. So we can map over these keys and then display each of the objects. So
just out of curiosity, if you tried object.entries of cart, would that also work? I get the feeling it would.
Does this conform? Is this what the shape of the result with object entries is? Let me just. I don't use object entries.
Yeah. So what object entries gives you? It gives you tuple arrays, if you will, right? So it gives you one big list of all of the entries, where each entry is the key and the value, and so it looks like the key is our product ID, and the value is actually the microstate value of the inventory.
Okay. So that works. So all we need to do then is we just need to say object.entries shop.cart, then map this, and it's going to give us it's going to be what is it, key value?
Yeah, key, right. Yeah. So that's like product ID and quantity.
Yeah.
Where quantity is actually the microstate and key is just a string.
ID.
Or ID.
Then yeah, and then quantity. So like that, and then return. Okay. So now we're going to map these over to a list of UL. Li. Okay, so now what we want to do here is we're going to need to look up each of the products. Okay, so then what we're going to do is, okay, so let's just do this here. Let product equal shop.products by ID, ID. Yeah, I hope that is going to coerce properly. Okay, and then product.title.state, and then let's do this. Product.title.state, and then so how does it work in the Redux example? Redux. Okay, so it has a total, and it has inventory and it has price. Okay, so
Where price is probably actually multiplied by its quantity.
let's see. Well, this is going to be individual price. I'm guessing. Yeah, it's individual price, and then let's see.
If you add another one to that, right? So you have two of those. Oh no, they're not doing that.
No, it's individual price, and then it sums it up at the bottom. So we'll do that.
Got it.
We'll do that calculation in a second. Product dot price dot state, and then times it's going to be quantity dot state. Okay, so what do we have here? UL.
Maybe it'll ask you for maybe a key on the li just to keep the
let's
happy.
So key.
You just do the ID, I imagine.
Yeah, ID. Yeah, that'll work. Okay, so let's see what happens here. Okay, that works.
Cool.
Okay, so now now let's do the actual summation. Span p total. Okay, so what we need to do is we need to actually calculate the total. So let's just calculate the total up here. So all right. So
that's pretty cool. We could make that as another like state getter
computation. Yeah.
Yeah, that's really nice.
Total cart total return. Okay, so what we got to do is we basically got to do the same thing that we did here, but we're going to do it up there. Okay, so all right. So can we do this dot cart dot reduce? I'm going to just do reduce here because it's going to be easier to. And then it's going to be 0. And so then that's going to give us the accumulator, and then the item is going to be the
tuple again, right? Yeah.
ID and then inventory. Okay, and so then what we want to do is so here it's going to be accumulator plus the ID, so we need to grab the product price. So it's going to be this products by ID. Give it the ID, and then price dot state, and then it's going to be times inventory dot state. Let's see if there's any type coercion problems here. I think it should be.
That's pretty good.
Reduce accumulator plus product by ID price state inventory state. Okay, so we should be able to take this.
This is where I'll get really excited. If you guys get the time to sort of solve how to integrate the ideas of microstates into TypeScript, because it looks like so far there's so many good things I'm seeing, and the only thing that I would call not a downside, but more of like a getting to know microstates is basically knowing when you have a thing that's a microstate versus when you just have a plain thing.
Yeah, I agree. No, it's definitely TypeScript is definitely on our radar, and there's some really interesting things that can be done. One of the things is that, and so I mean, there's the kind of low-hanging fruit, which is just simply having create, emit, like have a type properly typed, like the return from create being properly typed. But the other thing that's really interesting is, so there is when you call create, Microstates lazily does some it converts a DSL into a microstate data structure internal to each microstate object. And so if we could like somehow compile straight into a shape or some kind of a class that would just be typed by TypeScript naturally, like some kind of a precompiled step, so some kind of a preset, a Babel preset that would just like give you a perfectly typed TypeScript thing. Like I think that would be, that's what the kind of things that I'm thinking about. But I haven't had. We have a project right now where we're building a platform for a client, and they're going to be using a lot of the state machine stuff and TypeScript and Angular. So I think it's going to give us good motivation to really finish, like get the TypeScript bindings really tight. But I think this is essentially.
Yeah, that looks working.
And we're just under an hour and a half.
Yeah, sorry, I prodded a lot of questions. I'm sure this could have been a little faster, but I was kind of curious how some of the internals work, because like these are a few of these operations kind of got, I don't want to say hard, but they dig into some of the internals to like how me as a developer for an application would have to interact with microstates. Like what level of microstates internals do I really need to understand to make good use of it? And so I think this was pretty beneficial to kind of flesh that out.
Yeah, I agree. I mean, it's a different, like you said before, it's a different way of thinking about how to approach a problem. It has a kind of linearity to the work that is that I think takes a little bit of like it becomes easier once you get like used to it, and and also as microstates becomes more refined and more complete, it will just become more easier and easier in that respect. And like TypeScript bindings are definitely going to go a long way. But these kind of detours and these kind of videos, I'm sure, I think are going to add a lot of value to people, for people to be able to understand how the stuff works.
Yeah, I'm definitely really excited about the idea of creating almost like business domain primitives, right? So like I can kind of wrap up certain ideas. Like I guess the simplest example we had of that was the idea of inventory, where inventory is basically just a number, but it has these other concepts that are like business specific, right? Like if inventory is at 0, then like you're out of stock, right? So we could have even had like a get is out of stock, where it's just inventory state equals 0, right? And it's really cool to be able to create these little primitives that actually model business logic, not just business state, and use it in a functional way, which I think is maybe that's the thing that's so unique, because before you can maybe argue, oh well, we did that with the OOP, but to get that with functional programming guarantees as well is, I don't know, haven't seen that yet.
Well, you summarized really well exactly why we're building microstates, is try to build a level that would give us kind of a level where we can operate and talk about the business domain and have the technology kind of take care of itself. That's a lot of I think with the underlying layer that we have here with microstates, I think we've done we could see like an hour and a half we were able to accomplish quite a lot, and the pieces are pretty separate. You could unit test the shop separately from other things. You can now compose the shop into multiple shops, if you have that need for whatever reason. So the actual composition mechanics that we spent a lot of time designing, I think, are now working. And then the next step is for us to add that kind of next layer to domain specific kind of this domain DSL tooling thing, whatever this thing is being able to then have asynchrony alongside with your types.
Right.
So you can say that we have our API can be served by this library, and this library provides you the data models, the immutable data models for working, but also it knows how to go and get that data from the API and then format it correctly, so that any other team that needs to be reusing needs to work with the same data type, all they need to do is just import that and use it, and it will handle like asynchrony for them. And have the asynchrony compose, and then being able to like add middleware into asynchrony in a contextual way, like that's kind of the next. Now that we're getting to a point where Microstates is kind of pretty stable, it's not changing very much. The next step is actually is the asynchrony space, figuring out.
Yeah, that sounds awesome.
And we have, if you're interested.
Oh, I was just going to say, you brought up like, oh, you have this idea of a shop, and you could make multiple shops. You know, in a way, like I think Redux can do that, but I've honestly never done that myself. Is take like a whole Redux store and like embed it in another Redux store. But here, what we learned, like what you taught me for how to create a microstate and then embed a microstate in another microstate, like kind of like you said, it scales linearly. If I want to embed this shop in another or multiple shops in another store, like I already know how to do that because it's like the same way. It's like the composition is a fundamental primitive in the way microstates work.
Exactly. Well said. So this is if you're curious about the async stuff, the kind of experimentations that we are moving towards. This is I don't know what the actual example of this is, but so this is a runnable code, and it's there is a asynchrony. So this is like kind of experimentations around what the asynchronous stuff is going to look like. It's pretty early stage, but it's like a functional, like a working upload mechanism with state machines and all that kind of good stuff. So
awesome.
Yeah, it's got a lot of goodness in here as well. So, but you know, I mean, really, it kind of comes down to, I mean, I'm gonna if we need partners in doing this work because there's too much to do between Charles and I, and that's I think part of what we need to do more is try to recruit people to help us in some of these endeavors. That you know, especially with things that are kind of particularly interesting to them, like especially in the outside of microstate space, like in Redux, in those kind of external areas. I think that's where we right now I think struggle the most, is that there's just too many things that we can build domain specific things around, but there's just there's too few of us to do it. So
right.
Okay, well, I think we got. I think we did what we wanted to do.
Yeah, for me, for sure. Yeah.
Okay, awesome. Thank you so much for help. Thank you for asking me and for doing this with me. And your questions, I think, have been really fantastic. So I really appreciate it.
Yeah, thank you for taking the time. I mean, like for anyone listening, the story basically is I was poking around microstates and I was like, hey, I'm not sure if I quite know how to do this just yet. Like, do you have some examples? And instead, Taras here just said, oh, well, how about I just jump on a call and help you? So thank you for your time and thanks for showing me around.
It's my pleasure. And if anyone else wants me to help them, I'll be more than happy to if there's other use cases that the people want to try, I'm more than happy to give that a shot. I think it'll be really fun.
Right. My final question, have you ever heard of anyone using this on the server or Node?
That's what I'm actually working on right now. It's definitely so the use cases that where we're moving towards, especially with like front side specifically, because we're our projects are platform projects, and so there's a lot of building tools that scale well to complexities of large teams, like those kind of challenges. They require tooling that is more sophisticated. I mean, you could kind of see it. I think in many ways we've reached the limits of what people can do with object-oriented programming without functional programming and immutability. And you can actually see it in the way that in the tools that kind of emerge, like in recently, just now we're working with NativeScript, and NativeScript CLI has a bug where it doesn't clean up its memory usage, and so it basically leaks memory, and then if you open it like 5 times, you're like taking up a gigabyte of memory, even if it's closed, or when it's opened. So there's some kind of a memory leak, but I think a lot of that comes down to is that developers have tools and patterns that they're familiar with using. Like NativeScript is very much written like a Java. NativeScript CLI is written like a Java code base, and the patterns that they apply there, they don't lead to happiness. Like they lead to frustration because you ultimately end up having to manage challenging topics yourself. And so I think where these kind of experimentations, this kind of tools, what they do is lay a foundation for doing things first time correctly. And so what we're thinking, like and that's kind of what we're building towards, is having a suite of tools that you could use to build, like if you want to build a really robust CLI that just has like kind of like the best CLI that you've seen, like having CLI as a tool and having like a really robust CLI and just having like a really great experience and being able to make that easily, like that's what like Microstates is a foundation for that. And then on top of that, asynchrony, and on top of that, like some additional tooling. And then the result is going to be people just take a collection of things off the shelf and just build what they need. And it's just going to, like, it's just not going to give them the kind of problems that they're encountering today. That's ultimately kind of where we want to go with this tooling.
Awesome.
But yeah, definitely
ecosystem.
Yeah, ecosystem and server-side stuff is definitely interesting and stuff that I'm working on right now. I'm trying to, and we're hoping that in the near future we're going to get a lot more like GraphQL integrations, all kinds of stuff like that. I think that stuff is really interesting.
Gotcha. Yeah.
All right. Well, thank you, Alex.
Thank you.
It's great to meet you.
Yeah, nice meeting you.
All right. Chat soon.
All right. Have a good day. Bye.
Bye. Stop recording.